So 9.5. Just a quick little review of 9.4, tangent ratio. How I know it's a tangent ratio? Because I'm looking at my angle here, and I have opposite and adjacent. Okay. So quite simply, we say the tangent of 28 is opposite over adjacent. And hopefully you remember the little trick, whenever x is on the bottom, we just switch places. So x equals 13 divided by tangent of 28. And how do we do that on the calculator? We can just type it right in. Now, one thing to make sure you look at, you want to hit the mode button always, and make sure up here where it says rating in degree, it's on degree. Otherwise, your answer is going to be messed up. So mine's on degree, so I'm just going to type in 13 divided by tangent 28 equals. And there's my answer. I'm going to round it as it says in the instructions. Here's 10. So 24.4. Okay. On number 2, here's my angle, opposite, adjacent. So tangent of 39 is opposite over adjacent. In this case, you simply just multiply by 22, both sides, and again, you just type in your calculator, 22 times tangent of 39. And again, we're going to round the nearest 10th, so 17.8. And I'm going to leave number 3 down here if you want to actually practice the same type as number 1. Okay, so here is our new concept, sine and cosine. So we're going to incorporate this with tangent. Sine basically is opposite over hypotenuse, and cosine is adjacent over hypotenuse. And you basically, at this point now, know all 3 main ones. And you may have heard SOHCAHTOA before. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. SOHCAHTOA. Okay? I'll write it down and memorize that. Now notice how we see leg adjacent to A and leg opposite A. We've been talking about that already. And then we always know the hypotenuse is that longest side. So, example 1. It says find sine of S, sine of R, cosine of S, and cosine of R. So, we're going to be looking at first from S. Alright? And we're going to find sine. Well, remember, sine is so opposite over hypotenuse. So the opposite is going to be 63, and the hypotenuse is never going to change. That's always 65. So sine of S is opposite over hypotenuse. And you just divide 63 by 65. If you think about it, that was a test score. That's a pretty darn good test score. And it works out to be 0.9692. So it's around 4 decimal places. Now, for sine of R, we're looking here. Well, now the opposite is not going to be 63. It's all the way over there at 16. So when I do the sine of R, that didn't work out, right? Why did I want to change? Oh, I know what I did. I changed here. Sorry. The sine of R, still opposite over hypotenuse, but this time, like I said, it's 16 over 65. Now, if you think about that as a test score, it's going to be much lower, right? 0.2462. No, 0.2426. Sorry. Okay, I lied. I was right the first time. It was 6.2. Coming up, it's going to be, you'll see. Okay, so there you go. 16 out of 65 is basically 24%, 25%. 63 out of 65 is close to 97%. So that's where those decimals come from. Now we're going to do the cosine. Now the cosine of S, we're still starting from S, from what we have marked in black, but cosine is adjacent over hypotenuse. So we're going to use 16 over 65, which we already know from doing the sine of R what 16 divided by 65 is. 0.2462. I was looking ahead and had that written 26, so there was my mistake. And now the cosine of R, well, look at the purple mark. Again, we're doing adjacent, which is 63 over 65, and we already know what that is, 0.9692. So maybe you've already noticed something interesting, but the sine of S is the same as the cosine of R. And the sine of R is the same as the cosine of S. Because, I know how they say one man's trash is another man's treasure. Well, S, one man's opposite for R is another man's adjacent. Just depends on where you're looking from, perspective. Okay, so sine and cosine also have another interesting relationship, okay, from those opposite angles. If you think about it, in a triangle, if you have a right triangle, right? If that's 90, this is angle A and angle B, they have to be complementary. A and B are complementary angles. They have to also equal 90 to make 180. So, if they are complementary, then look at this. The sine of A is equal to the cosine 90 minus A, which gives you the cosine of B. Okay? So they have this very interesting relationship. The sine of B is 90 minus whatever A is. And you'll see that in action here. Okay, so write the sine of 56 degrees in terms of cosine. Well, cosine of 90 minus that degree, 56 degrees, means sine of 56 is the same as the cosine of 34. So if you kind of wrote them underneath each other, 56 plus 34 makes 90. So the sine of 56 is the cosine of 34. If you think about it easier, sine of 50 is the same as the cosine of 40, and so forth. And the cosine of 10 is the same as the sine of 80. And that will not change. Okay, example 3. Find the value of x and y using sine and cosine. So we only have one angle. Now, of course, technically, we could do 90 plus 26 and subtract and find out the missing angle. But we don't need to. Because from 26, we can take the sine opposite over hypotenuse. Sine of 26 equals opposite over hypotenuse. And we can also do the cosine, which is adjacent over hypotenuse. Okay. In both cases, notice our variables are on the top, so we're literally just multiplying both sides by 14. in both problems. So when we do that, 14 times sine of 26, just type in your calculator, you will get 6.1. It says round nearest 10. And we type in 14 times cosine of 26, you will get 12.6. That's for y, and that's for x. A lot of calculator work here. Okay, it says find a sine cosine for a 45-degree angle. Well, we don't have a triangle. Well, it's very easy. We know that a 45-degree angle is an isosceles triangle. We can pick any number we want. We can make the length 17, 35, 1,000, or we could make it easy on ourselves, just make it 1. And what's the relationship? We take the leg times root 2. Well, 1 times root 2 is simply root 2. So we can do this now. The sine of 45 is equal to the, sine of 45, sine is, so, opposite, which is just 1, over the hypotenuse. And all you have to do is type, you don't have to rationalize this, to try and find the decimal. So when we type that in the calculator, we get 0.7071. And the cosine is going to be the exact same thing. Why? Because the legs are the same. So the opposite leg is the same as the adjacent leg. So we're going to get 1 over root 2, and again you get 0.7071. Notice we use 4 decimal places when we're talking about this stuff. Now for 5, we're going to do the same thing. Similarly, draw a triangle. We know this is 30 because it's opposite the short side, which makes this 60. Again, we always want to start from the short leg, so why not make life easy? Make it 1. The hypotenuse is double that, and the long leg is just 1 times root 3. So, from 30, the sine of a 30-degree angle is going to be opposite 1 over hypotenuse 2, which is simply 0.5. But we're using 4 decimal places, we're going to write 5,000, 0.5000. Now the cosine of 30 is going to be adjacent root 3 over 2. Type that in the calculator, and we get 0.866. And we're just going to tack on a 0 and take it out to 4 places. And one last example here. A little skiing. So, the altitude is 1200. The angle of depression here is 21 degrees. Well, 1200 is the opposite side. We're trying to find the actual distance on the slope, our x, which is our hypotenuse. I can spell. Okay, which is always opposite or right angle. So this is a simple sine problem. We have opposite and hypotenuse. So sine of 21 equals opposite over hypotenuse. When the x is on the bottom, we switch places. 1200 divided by sine of 21. We just type in our calculator. And what we get is 3348.5, and it says round to the nearest foot. So that's about 3349 feet. And that's it.